Hello everyone, welcome to my channel. In this video, we are going to discuss about the chamber method of ventilation, which is the most crucial things I think that auxiliary ventilation system. As because you know that this is the chamber method of ventilation rarely been used in a mine, and you know that in the right side I have given the figure of the circuits, as because this is the most crucial ventilation circuit as well as the most important thing. If you see that this is the this case of chamber of ventilation system generally used in the longwall mining, as because I know you have very good concept regarding longwall as well as your board and pillar system as well as or room and cooler system, as because you know that there is a top gate and bottom gate. This is the main gate, this is the tail gate. Okay, so in case of auxiliary ventilation system, you know that is R1 and R2 hereby given, that is the regulator, and D are the basically the doors. Here the oxygen comes through here and it will go to the top gate. Okay, it will go to the top gate and it will go to the return area. That is, one rise is the return area. Okay, one chamber fan is there which can boost the air. Basically this is the booster ventilation, as because this is called a chamber. Okay, so that's why you see this ventilation circuit is called that the chamber method of ventilation, as because this is the GOF and you know that is the power support and that is the AFC, as well as this is the I think CRR also there. Okay, it may be darts, it may be SARS, that is double ranging drum CRRs as well as the single ranging drum CRRs. So at some of the places, leakages of air from surface to cracks or where the GOF of a working becomes a serious problem, as because if GOF breathing is there, so there is a big problem if it is a leakage of through surface cracks or due to the subsidence, and you know that that is the most important thing for a mine maintenance system. There is no crack should be there and crack should be filled up by the material. Okay, so to deal with the problem, fan pressure has to be reduced, resulting the reduction of airflow rate at the mine, so that your fire portion of fire cannot be aggravated to the other portion of the mine, as well as the mine will be your safe and the mains are safe and the other society will be safe. To address this problem, chamber method of ventilation has been developed. It is a ventilation arrangement which is superimposed on the mine ventilation system to reduce the cumulative pressure drop in a desired area, responsible for leakage of air either from surface or other GOFs without affecting the main fan pressure and the ventilation in other parts of the mine. So to address the problem, chamber of method of ventilation, here it is strictly I have written here that in case of ventilation arrangement which is superimposed to the main maintenance system, as because main maintenance system means there is intake airway, there is a return airway. It is simple as that, but regulator will be there as well as the doors are also will be there, and there no door should be placed in a leakage way, as well as the regulator should be placed generally in the return airway. Okay, so here also you can see that is the return airway. Here also the regulator has been given so that you can control your air in the working phases. So the responsible for the leakages of air either through the surface or through the GOBs, it may be the leakages can be air through the maybe leakage from the GOB or through the surface. So this is the most important thing for the pressure drop in the desired area and responsible for leakages in the area. Okay, so next is the basic requirement of the system for implementation. Here also I mentioned here the ventilation survey the data, I means the quantity, area and the velocity of the air. I mean velocity into area is equal to the quantity. Okay, so the quantity means air quantity of that portion or that working place through computational studies for working out design parameter of the system. This is a very easy simulation studies I'll show. Okay, so conversion of affected area into the chamber by closing cross connections. Cross connection will be there, and axial flow, I told you earlier that axial flow of fan, generally all fans are axial flow plans, as because that is the so that the capacity of the fan will be increased, as well as the no chances of fires and no combinations and safety to inculcate the safety of the mines axial fan is required for the compatible to the main fan, as because main fan will be the axial fan and main fan generally also the axial fan. Okay, so two regulators of variable apertures R1 and R2 I have mentioned earlier, and I have shown in your last slide that R1 and R2 are the regulator. Regulator R1 is meant for the creating pressure difference across the panel to achieve the optimum flow of air. I told you to control the air and to maintain the pressure balance, as well as to optimum adequate quantity of air to be reached at the working phases. Okay, and the minimum leakage of air into the gob, as because your door should be leakage proof. And the purpose of the regulator R2 is to raise the pressure of a chamber to the desired level, so that gob pressure remains slightly positive compared to the atmospheric pressure, so that no fire will be conducted. Okay, so advantages of this chamber of ventilation system is optimum airflow rate can be maintained with minimum leakage of air into the gob. I told everything regarding this. Optimum airflow means adequate quantity of air can be reached at the working phases, as well as the minimum leakage of the air, as because the doors are there but leakage proof doors are required to achieve the target of your gob. And leakage of air and influx of noxious or carbonaceous as well as the inflammable gases in the area from the part of the mine, it is totally stopped. And the environmental monitoring condition of the gob becomes easier, which may help in early detection of the spontaneous combustion, as because you will get the direct data of the oxygen percentage, as well as CH4 percentage, CO2 percentage, CO percentage, and the H2S percentage, so that you can generally get that what are the condition, as well as the wet bulb temperature and the dye bulb temperature of the inside and the outside of the stoppings, so that you can achieved your target. I mean the inculcate of safety. I mean this is the enough for chamber of ventilation system. As well as if you have any doubt, you can ask me in the comment box. And if you like this video, please like, share, comment and subscribe to my channel, as because this is the channel I have grown so many times, and you know that is the most important channel for the mine ventilation as well as the other thing. And if you want to visit the mine, you can go through the description, and I have already given the link of the description box, and you know that is the only description where it is the mine only visited you can through internet. Okay, and in the previous lectures of the regarding mine ventilation also I have given the link in the description box, so please show the link and please subscribe to my channel and don't forget to press the bell icon. Okay, for the further notification. Thank you, best of luck.